Hey, before we get into today's lesson about absolute value and solving those, I just don't want to forget about how to use that. So here we're just going to use some evaluating skills. So I'm going to plug in 2 times negative 2 minus 5. All this stuff is inside that absolute value, plus absolute value negative 3 times negative 2. This is inside of its own absolute value. And all that means is we're going to do some solving in here to get some things going. So here we got negative 4 minus 5. So that's negative 9. What's the absolute value of negative 9? Yeah, I hear you. It's positive 9, right? Next term that we have is plus absolute value of 6. Well, what's the absolute value of 6? Well, that's still 6. And then minus 11, because that's what was happening on the end. So we're going to add these up. I get the whole way up to 15 minus 11, so I get 4. Okay, so just don't forget, as we work on some things today with the absolute value, is that we can use it kind of in the order of operations when we're trying to evaluate to simplify an expression. All right, so let's take a look at what we're going to do today. Looks like we have absolute value with greater than signs, equal than signs, and then some extra stuff going on. So here's what's going to happen. We need to talk about the absolute value today. And what that means is whatever's in the absolute value, we're going to leave it alone. So I got 3, I'm going to change it to x, just because I like to do that. All right, so what we're saying is 3b minus 1 has to turn out to be 11. But the other thing this whole thing right here could be is if this turned out to be negative 11, what's the absolute value of negative 11? Well, it'd still give me 11. So we're going to work with the other half of this as well and say it could have been negative 11, and that would still give me the same answer. So we're always going to write two equations. The first one is identical to what we have, and in the second one, we're going to change out that 11 for negative 11. We always want to have that alone first, and that's what we'll talk about in the next part. I do like to set them both up just like this when I get started because the solving steps are going to be exactly the same. So it'd be kind of silly if I didn't just go ahead and do that. All right, now notice the numbers themselves don't come out to be the same, but what I'm doing to solve each time, right? Adding 1 to each step, dividing by 3. Okay, so x turns out to be 4. So if I plug 4 in here, it'll work. The other thing I could plug in is negative 10 thirds. All right, that's what, 3 1/3, negative 3 1/3. So those are the two things we're going to do, okay? Let's take a look at the next one. This one looks a little bit different, right? There's something extra going on, right? This minus 25. So what we need to do is we need to make it look like the first one. So that's one of our unwritten rules of working with our absolute value is it must be alone, okay? So since it is usually unwritten, we're going to write it down there. Must be alone. Okay, and what we mean is the absolute value must be alone. So we're going to add 25 to both sides before we do anything else. So I'm still going to show the absolute value of y plus 17, absolute value equals 15. And now I'm ready to write my two equations right now. Okay, so I have y plus 17 equals 15. Now if y plus 17 turned out to be negative 15, this would still work. Y plus 17 equals negative 15. Now we're going to solve both of these by doing the inverse operation, which is now subtract 17. All right, so we have y turns out to be, this one's a little bit easier, right? Negative 2. Maybe this one's easier. It's still going to be negative, but I have to add it up. So 15 and 15 would give me 30. It's 2 more than that, so it's negative 32. All right, so the absolute value must be alone, and then we're going to continue writing two equations for each one. All right, so what do we have to do before we can get started with this problem? What I hope you notice is get rid of this 2. So that's the very first thing I'm going to do is just add 2 to both sides. Okay, so I'm going to go ahead and strike them out and call it 7 because that is what needs to happen. That way I can go ahead and write my two equations. Again, I'm going to change my h into x. So x over 3 plus 4 equals 7. That's the original one. So x over 3 plus 4. This whole thing could also turn out to be, right, because it was inside the absolute value. If this turned out to be negative 7, then that would be okay. And now we're ready to do some solving. So here we go, minus 4. And notice that step happens everywhere. So I got x over 3 equals 3. And I'll have x over 3 now equals negative 11. Now, we all know if x is being divided by 3, we're going to multiply by 3 to get rid of it. Okay, so it seems like we're writing a whole bunch of stuff But just keep in mind, that's why I wanted to set up the problems at the same time. I don't want to just solve one because the solving steps are the same, even though our numbers come out to be different. Okay, if that bothers you, go ahead, get them both set up. So what I have here in the orange, I do like to see that right away because often kids will forget to write down the other half of it. But if you'd rather just solve one of these completely and then go solve the other one, but make sure you're up to this orange step like I had just highlighted. All right, something's different here. Yeah, the inequality, right? So that means we're going to treat it just a little bit different, but not too much. I do want one inequality that's exactly the same. But now I have x minus 3, and you know we're going to use -5, right? But remember, with the inequality, there was also an extra rule that had to change the inequality. So now we're going to flip-flop the inequality while we make it -5. So those are going to be our two inequalities to work with. And then we're going to add 3 all over the place. So we're down to x is greater than 8 and x is less than -2. So that means we could take and place this on the number line. So here's my 0. I'm going to call this -2. So this can be 8. And we want it to be greater than 8. So I know it's going to be open and to the right. And it's going to be less than -2. So another open circle, and less than is going to be to the left. Okay, so we start to see that this is one of those or inequalities, right? Because I have the left or the right, but I don't get the things in the middle. Okay, so the big key here was change out that inequality. When we go to make 5 -5, we also have to flip-flop the inequality. All right, so all by itself, so that's a good thing. So 2x is greater than 16. What's the other half going to be? 2x stays exactly the way it is. I got to change the inequality to less than -16. That means these would work. Divide by 2 all over the place. X is greater than 8 and x is less than -8. All right, so again, we can put these on the number line. 0, we'll call this 8. We'll call this -8. We're going to be less than -8, so it's open circle and shade to the left. Greater than 8, open and shade to the right. All right, so we're really using the absolute value to create a situation where we have multiple equations in what we're trying to do. What we just done in the last section with those compound inequalities. Okay, so all I did here is, well, as I was talking about that, was write the first equation, the identical one. Now we need 2x minus 1 less than or equal to -7, and now we're in business. We're ready to solve all over the place. So plus 1 everywhere we go. People want to know. John Jacob Jingleheimer Schmidt. All right, -6, here we go. All right, so we just continue to solve all over the place. X is going to be greater than or equal to 4 as I divide by 2, but it's also going to be less than or equal to, divide by regular 2 here, -3. Okay, so let's take a look at that on the number line. 0, we're going to call this 4. Notice it's equal to, so we're going to make that a nice solid point. X is greater than, so we're going to the right. And let's call this -3, solid point, less than to the left. So we get those things taken care of. All right, next problem we have, kind of the same thing. 8x minus 16 greater than 16. 8x minus 16 less than -16. All right, let's see what happens here. We know we're going to add 16 all over the place. So 8x is greater than 32, and 8x is less than 0. Does that mean it's a no solution? No, 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 no. That just means we're going to have to deal with the number 0 on our number line. And here when we divide by 8, we're going to get x is greater than 4. So that means my number line has 0 and 4 listed on it. They're both open. We're going to be greater than 4 and less than 0. These all happen to be less than so far, which is causing that or combination. All right, you can see the next one. Just to beef it up a little bit, I just want to review how do we solve when it has this b over 2. I think we're going to do good with that. So I'll just kind of work through some steps. Remember, x over 2 minus 1 is greater than or equal to 2. Second equation, x over 2 minus 1 is less than or equal to negative 2. And we're just going to keep solving here. So add 1 all over the place. So x over 2 is greater than or equal to 3. And x over 2 is less than or equal to negative 1. All right, currently, we are dividing by 2. So what should we do? We're going to multiply by 2. Okay. And I hope you see why I like to set all the problems up at the same time, because the solving steps are the same. We're just kind of mentally thinking about the different numbers. So 2 times 3 give me 6, greater than 6, less than or equal to negative 2. And reviewing again. So here's my 0. We'll call the 6 way over here. Negative 2 is over here. We got closed circles this time. Greater than 6. All right, we're going to the right. Less than negative 2. We're going to the left. So then outside one more time. All right, got a little star next to this one. That means there must be some extra stuff going on with it. And I think we can handle that. Remember, the absolute value does have to be alone. It doesn't matter if it was an equal sign or an inequality. So we have to do a couple steps to get this alone. And the first step you would do is add 10. Okay, so to save some space here, I'm going to turn this into 40. Our second step, my dear friends, is to divide by 2. So we're down to 2x inside the absolute value plus 26. Close the absolute value is less than 20. And now we're ready to start actually writing our two equations. 2x plus 26 is less than 20. 2x plus 26 is greater than negative 20. And now we're in business here. We're going to subtract 26. That was just a 20 there. Right, so it looked like it was a big, bad, impressive type of problem. But it just turned into a two-stepper just like everything else. We just had to do 2 steps to get to where we needed to be. So x is less than negative 3, and x is to be greater than negative 23. All right, so we could throw those on the number line, but I think at this point we have the idea. Just remember that it would be open circles along with our shading, because that's what we have been working on. All right, before we part here, typically on these video days, all you have to do is go through those. What I'd like to see, what I'll be reviewing before you come into class, is that you complete these 3, 13 and 14 in review, and 10, that's from what we're working on today, just to have an idea to show your understanding before you come in.